Okay, we're going to look at the excellence component of this particular problem. And we've worked out the original question with 43 and 56 as the combination with a max of 126,920 or whatever. Now, with the second part, what happens is we've changed the objective function. Okay, so we've changed the objective function so that the Y value, the number of bagels, is changed. The profit that they're going to make is changed. So the objective function is no longer the same. It's changed. It's 1872x plus 468y. Okay, so that's the new objective function. Now, when that happens, that means that when we stick, like the vertices are all going to stay the same. The feasible region doesn't change. So these vertices that we found already from the above question are going to stay the same. But when we throw them into a new objective function, obviously we're going to get a different profit. So we need to know what happens with the profits for that. So what we do is we stick them in. Now you can organize it into a table, but you don't have to. But you're just going to have to retest your vertices 9 and 124, 9 and 16, 53 and 16, 43 and 56. And you've got to stick them into the new, which is this new basically profit function, objective function here. And we're going to get these profits. Now what you'll notice is we get this really strange thing happening. We get 2 points that are giving us the same profit. We're getting multiple solutions. Now, why are we getting multiple solutions? Why is that happening the way it is? So we have to notice that because we're getting multiple solutions that max out the profit here. And then we've got to do a little bit more investigation into that and what that all means. And then we've got to kind of give, besides the 53, 43, 53, 16, 43, 56 combination that gives us that, we need a few more points that we're going to need to do. So let's just take a look graphically at what this looks like and why it's happening the way it is. So the reason that this is happening the way it is because here, this orange line represents the original objective function. And as it goes through the feasible region, we see that it exits out at about here, this last point, 43 and 56, right? So that's what happened with the original objective function. But what I can do on Desmos is I can type in a new objective function, and the P slider still works for this. So I just click it on, and then I can see that it's going to move through the feasible region. But what happens as it exits is very, very important. What happens with this objective function as it exits is you will notice that it's parallel to that back line, right? To this particular equation here. It's parallel to that. So what happens, because it's parallel, it's going to end up giving us multiple solutions, because as that thing exits or basically bangs up against this line that it's parallel to, we then have this point and this point are going to give us the same objective function. They're going to give us the same. Now, this is a bit of an estimate, so it's not exactly on, but it's going to give us a profit of around 107. I think in the one note, we ended up getting, what did we end up getting? 106,704. So it's just a little off of that, basically. And so we end up getting these 2 points, which are in the feasible region, giving us the same profit. And that's why, because this objective function is parallel to this back line. Now, any point between here and here is going to give us exactly the same profit. Exactly the same profit. Now, what you should do is try to find some whole number values like 45 and 48. Try to get some whole number values because we're dealing with batches, 48 and 36, 50 and 28. So those are other combinations that are also, besides these 2 points here, that are going to give us maximum solutions, multiple solutions of this. So any one of those combinations I just showed you. Now, what we're going to also have to do probably is do a little bit of a proof around how that's parallel, because we're not going to have the Desmos to show them. So what we're going to have to do is basically prove that this equation, this profit function gradient, is the same as this one, the one that it backs up against. So we're going to have to do a little bit of algebra. So to do that, we basically just take this equation and we subtract, subtract 1872x, right, to the other side, so that we end up getting 468y is equal to negative 1872 plus the p, but we don't really need to worry about the p. That's not going to give us the gradient. And then at the end, we divide by the 468, and we end up getting a gradient of negative 4x, or negative 4. So we do the same thing down here. We get the 3y and we subtract the 12x plus the 684. But we're only interested in this. And then we divide by the 3 and we divide by 3 and we get negative 4 for gradient. So basically those two things have the same gradient. That's why they're parallel. They have the same gradient. Those lines have the same gradient. And that's what Desmos is showing us. It's showing us that this line here has the same gradient. It's parallel to this back line. So we've just proved that. So then you would say, well, we found that the objective function is parallel to this equation with a gradient of negative 4. And because they're parallel, we'll get multiple combinations of muffins and bagels that will give me a maximum profit of 704. And so we find whole number solutions between here. So we can go back. We don't need to do a lot of math. We just go back to Desmos and say, Desmos, find me this. So I just click on here, right, and find some other whole number values. I'm just going to run my mouse so it's a little bit easier than my pen. 45 and 48. 45 and 48. So if I go 45 and 48, 45, 48. That's another combination that works. Find another one. Find a couple more. 50 and 28. Okay, 50 and 28 will work. That's a whole number. 50 and 28. So we've got these, we found some extra ones. These are all whole number solutions that will give me profits of 106,704. Multiple solutions, and the reason for that is because the objective function is parallel to that back line, and so we're going to get multiple solutions. And so that's how you answer the excellence question.